Good afternoon. Assalamualaikum, everyone. Yes. See new face today. Okay, some of you maybe just enroll and just join the class. Yesterday we had stopped at error, right? For example. But before that, I want to clarify on this calculation. Yesterday, using calculator, I cannot calculate for the sin power 2. Okay. So how to calculate sin power 2? Square? Square, yes, correct. Sine 0.5 square. Okay, so using calculator, this part, you should put sine 0.5 square in the calculator. Okay, let's try. I already download this, so easier to teach you. Now, see, we try to calculate. Okay. Okay, wait, I haven't shared the screen. Have I? Okay. Okay, so this is how to input in the calculator in bracket sine 0.5 close bracket power 2. Okay, power 2. So it depends to your models, calculator models. Then minus 1/3 close bracket multiply 0.5. Okay, the one that I want to focus on is this part, sine 0.5 power 2. That's how you input in your calculator for sine 2 0.5, sine power 2 0.5. Okay, so equal, you'll get the figure. But make sure your mode is in radian. If you use degree, you will get different value. Okay, if you use degree, you will get this value different. So make sure you use mode radian. Okay, can This is how to input in your calculator. Sine power 2. Okay, now we move to chapter 1C, source of error yesterday. We stop at here, the example. Okay, we start with the example. Using the following infinite series to approximate exponent 0.5. Okay, so this 0.5. Okay, so 0.5 here is the x for this function. Okay, so this is the long version of the function. Okay, exponent x, the Taylor series. It asks you to carry out the calculation until the absolute value of the approximate percent relative error falls below error criterion, conforming to 4 significant figures. Okay, the calculation until absolute approximate error falls conforming to the 4 significant figures. Using this info, we can calculate the ES. Okay, where n is the required significant figures. So here, clearly it mentioned 4 significant figures. We need to calculate what is the ES. Okay, by replacing the n over here with 4. What you get? What do you get for ES? 0. 0.0030. 0. Okay, here you will get 0.5 power of -2%. Then -2, so 0.005. Correct. Correct. Right. So this is the percent, 0.005%. So this is your stopping criterion. You must stop at below this error value. Okay. Up to that, can I? Okay, first we identify what is our stopping criterion. Then find the true value of exponent e power 0.5. Try to calculate using your calculator. Do you get the same value or not? E 0.5. Can get? Okay. E, this one, sorry. E 0.5. You get the same value. Okay. Now the ES we already got just now, 0.005. So you must stop when your EA below than this value, below than ES. Okay, then how to proceed? Remember just now the equation, where I copy the equation over here. Much easier. Okay, just put it here. Now, this is the equation. So first iteration is using only the first term, meaning that up to here, first term. Exponent x equals to 1. So E 0.5 equals to 1. Okay, we stop up to here. So you need to find the true error and also the approximate error. How to calculate true error? True value minus the approximate value over the true value. Okay, then you will get this percentage. This one is ET. EA is the current approximate minus previous approximate over current. So for EA, the first iteration, we don't have the previous value. So the EA for the first one is not available because we don't have the previous. This is your current value. Okay, we don't have previous. Now move to the second iteration where it includes the second term. 1 plus x. Okay, this is the second term. So exponent 0.5, 1 plus the x. X is 0.5. So this is your approximate value. Repeat the same step to calculate the error, true error, and also the approximate error. Now, the approximate error, now you have the previous value. So 1.5 minus previous value, which is the 1. Okay, now this one is already previous. Over the current. Current is 1.5. So you get this approximate error. Okay, you see over here, the approximate error is 33.33%, where your ES is 0.005. A long way to go in order to get lesser than 0.05. We focus on the EA. Okay. Now you should do following iteration until you get the EA lesser than the ES. Okay, so go for third iteration. Include the third item, the third term. X power 2 over 2 factorial. This exclamation marks means factorial. Are you familiar with this factorial? Familiar? So this one, what does it mean? The factorial. What does it mean? 2 multiplied by 1. Factorial. If 4 factorial, yeah, 4 times 3 times 2 times 1. Okay, how do you input in your calculator? Symbol. Symbol of factorial. This symbol here. This symbol, the factorial, under the mode. So let's say we calculate for this, the third iteration. 1 plus 0.5 plus 0.5 power 2. Okay, over 2 factorial. And you get the same answer. Okay. Okay, did I go too fast? Clear? Okay, continuing to the next iteration, 4 and 5th iteration, until you get the EA lesser than 0.005. Okay, try to calculate until what iteration that you get. EA lesser than 0.005. What iteration to get lesser than 0.05? Six, you get 0%. EA. Right? Some of you I see at seventh iteration. What's your name? Alif. Alif. Okay, Alif got 6 iteration with EA 0%, right? Naresh get EA at 6, also 0.0015. Okay, so from here you can see the difference between the EA percentage. Why this is different? Because due to the decimal point. Some of you at 6 still didn't get the below 0.005. It's all due to the decimal point that you use. Alif, you use how many decimal point? 3. You remain 3. Okay, if the rest use 4 decimal point, then you will get different EA value. Okay, so as long as you can prove your iteration, the EA is lesser than the ES, then you can stop your iteration. Okay. ET at the 5th iteration, you already get 0%, right? Okay, the EA because it compare the previous and the current value. Okay, any question? Or can get anyone stuck somewhere? If the EA, your EA is a random value, that means go down and go up, then something wrong with your calculation. It should be decreasing. The EA should be decreasing. Okay. Okay, for those who are done, try again with the same equation, but x equals to 1.2. E 1.2 with the same equation just now. Wait, let me copy the equation first. First step, you should find the true value first so that you have a number that can benchmark with. Okay, your x is 1.2. So first step, find the true value first. Okay, step 2, then only proceed with the iteration. Fix your decimal point that you want to use. Okay, but in the question just now, it's already mentioned 4 significant figures. Okay, so fix your 4 significant figures, meaning that you have 3 decimal points. What do you get for the true value? E power 1.2. 3 point? Correct. 3, 2, 3, 2, 0. Okay, I'll call out names for attendance. Rabia, Aisha Khalida, Ariana, Tang Yok Ling, Tasmia, Sabah, Go Petong, Alif, Anis, Balkis, Tiang Sun Ling. Naresh and Ruben, your name is not in the list yet. Your name is not in the list. Not yet. Haven't enrolled. Okay. Ruben? Okay. Okay, how many iteration you get? Quite long. Huh? Until 16? 6. It should be around 9:30. Okay, around 9. The final value should approach the true value 3.3 something. If your final value is 2 point something, then something wrong with your calculation. And if you get 9, 0.003, then E8 0. E8 0. Okay. 0. 9 acceleration. Yes. If you are conforming to the fourth significant figure, you get 0. Okay, Samba using public five significant figures. So she gets 0.003 at the 9th iteration. Okay, so here the main point is your EA until lesser than the ES. So from here we can conclude until 9th iteration. The value should be, Alif, what you get your value? 3.32. Sorry, 3.32. Sabah? 3.198. Okay, so notice that your value approaching the true value. This one already true value. Okay, your true value just now is 3.32. If you get, if you deviate too much from the true value, then something wrong with your calculation. Okay, so that is your benchmark, the value of true value. Okay. Any question? Okay, I give 5 minutes for the rest to finish, then for you to break. Later I continue the new chapter because we are done with chapter 1. Later I will continue with chapter 2A, locating the roots. For the finite series in your notes, you have finite series after this. Okay, but I have moved that topic to chapter 5 because it relates with chapter 5. Okay, so to conclude this topic, this one you can try on your own. No, this one is the one that we do just now. Okay, so another error is the round off error. Previously, we have the truncation error, where from the Taylor series, you truncate according to the term, first term or second term, up to until you get the lower percentage error. Okay. Now for the round off, as you know, for the decimal point, sometimes you round off, right? Let's say for pi value, 3.142. This one is standard general that we use. But if you press the calculator, it will give you the longer version of the pi value, right? So what is it? 3.142 what? Okay, 3.142. 3.159. Okay, this is from the calculator. So if you round off to 4 significant figures, it will be only 3.142. This is the general value that we always use in our calculation, right? Okay, so if you use this longer version of the pi, you will get your answer much more closer to the true value, perhaps with a lower percentage of error. Whereby if you round off it, so the error might be a bit higher compare using the more decimal point over here. Okay, so this is round off error. You round off the value. Okay, you pay, let's say the price is 3.17, 3 ringgit 0.17. So how much you should pay? 3.2, right? The cashier will round off to 3.2. The system will round off to 3.2. So in actual percentage, they have a few cents more. If it accumulates, you get more. Okay, okay, that is round off error. Okay, so as of now, we have the truncation error and also the round off error. The truncation error just now, we have two types of error, which is the true error and also the approximate error. Okay, so you should know the difference by now. What is true error and approximate error? True error using the true value. Approximate error using the approximate value. What is ES? ES. Significance error. S stands for significant error. Where? Okay, this one is significant. Significance error. Where you have the equation 0.5 multiply 10 to power 2 minus n. The stopping criterion. Okay, if it is not given, so you should know what is your significant figure. Then only you can calculate. Otherwise, the question will just directly give you the ES. Okay. This error calculation you will be using in all of your calculation later on. Okay. Can any question for topic 1? Intro to error only. Okay. Now I move forward to chapter 2. Locating roots. First of all, you need to know what does it mean by the word roots. Okay, roots over here meaning the x value. When y equals to 0. Okay, and this topic only involve the non-linear. Okay, non-linear equation. X power 2 and above. Okay, and to find the roots of single equation, we have two major methods, bracketing and open method. Bracketing, what brackets mean? You have open bracket, close bracket, right? So it is in between in that bracket only. Now, bracketing method here means you will be given lower value XL and XU. Lower value and upper value. That this value is the one that will bracket your root. Meaning that your XR is in between the XU and XL. Okay, the one is as overall bracketing methods. In the bracketing methods, we have three more sub-methods, which is graphical method. You need to draw the graph in order to find your XR. Or you can use formula. These two is using formula. Bisection and false position method. All these three methods aim only to get the roots value. Either method that you use, you will get the same answer of XR, the root value. Okay, for the open methods, you will be given either 1 or 2 value for your starting point. Here in open methods, don't have the lower and upper range. Okay, that one we will go in details in open method later on. Now we want to focus the bracketing methods. Okay, now for the graphical, I'll explain you in detail. Okay, let's say you are given this equation, quadratic. Can see ah? Can see ah? Okay, quadratic power 2 positive. How is the curve? Right, smile. Right, so let's say like this. Okay, this one just a rough estimation. Huh? Now, here you see when again x r, which is the root, is when y equals to 0. So here is your xr. When y equals to 0. So you have two xr point over here. xr1, xr2. In this case, okay, it is not always have 2. It depends to your equation. Okay, and it depends also how is the curve. Okay, so let's say for xr1 over here, xr1, so it between xu and xl. It must have xu and xl. You must have that upper range and lower range, so that you know where is your root false. Okay, so your XR over here must be lower than XU, greater than XL. Notice the sign different. Here is positive side, here is negative side. Okay. So for the XL over here, you will have Y XL, and then at XR, your Y is 0. Okay, so the XL over here is the negative side. This is the root place and positive side. Okay, so usually the range will be in different sign. One positive, false in that two different region, because we want to find the X at Y equals to 0. Okay, so for XR2, you will have another XU over here. So for XR2, the limit is between XU2 and XL. Okay, understand the concept now? The XR is when Y equals to 0. Now this slide, it explains you from the beginning of the process in order to derive the equation. I will not go through yet this slide. Okay, I will just give you one example so that you can understand clearly what is locating the roots. Okay, now, first method, we go for graphical, meaning that you need to draw the graph. Okay, using this example, given this equation, it asks you to locate the root which is between 10 and 20 using graphical method. Root here is the XR. Sorry, I changed the color. Okay, XR. Now 10 here is XL, your lower limit. $20 is your upper limit, XU. Okay, next, what you need to do? We already identified. So your XR is in between 20 and 10. Now identify what is your YL and YU. How to identify it? Using the equation over here. Let me know if you cannot follow. Okay, this is first step. Identify your range. Now putting the 10 into the equation. What do you get for YL and YU? Try to calculate first. Okay, what you get for YL and YU? Alif, what you get for YL? Positive, negative? Positive. Okay, 0.0135. Correct? YU? YU? Correct. Negative 0.585. Okay, so negative 0.585. You see the upper range, it gives you Y with negative value. Lower range with positive value. Okay, so we are running out of time. Complete all of these value for the Y use from X12 to 18. Okay, try to complete. Tomorrow we continue. Okay, for step 2 over here, since the question, it doesn't give you any step size. Okay, so here we assume step size equals to 2. It's up to your assumption, but now I'm using step size equals to 2 to ease the calculation. Okay, so that's why we can get 10, 12, 14, 16, 18, 20 over here. Now the rest of the y, try to calculate. Tomorrow we continue. Okay? Okay, so that's all for today's class. If you have any question, can ask or can text me in the Teams.